So optics is another study that we're going to do with light, and we introduced light in the last unit, and we're moving into optics in this unit. There are different areas of optics. We're going to be focusing on geometric optics, looking at light as a ray, and light, going in a straight line, and and it can bend, it can refract, it can reflect, and so we'll be doing that. Physical optics is looking at light as a wave, and we'll do that if we have time after this unit. And then quantum optics, light as a particle, and some really interesting things there that we'll dive into when we get into quantum. So reflection is where light bounces off a surface, and there are two types of reflection. We have specular and we have diffuse. A great example of specular is obviously a mirror where it's a shiny surface. We can clearly see our image. And diffuse, it's a rough surface, and we cannot. And so this could be like something that's white, like a wall, and we're looking at it, but we don't see a reflection because it is reflecting most of the light, but it's on all sorts of different directions, and there's no continuity with it, and we can't make out an image from it. So this would be like, having an object, like I don't know, like a star here, and the light's coming from it, it bounces and then comes straight into our eye, and we can make sense, versus a light source coming in and then bouncing off a rough surface. All the rays are all sorts of different directions, and it doesn't make sense when it comes to our eyes. So mirrors are great reflectors, and we're going to be looking at that, and we're going to be using rays. Now, mathematical rays never bend, but light rays can, and they interact with materials. This is a light ray bouncing off a mirror. And so what I want you to do is go ahead and draw a rectangle. The positive side is the shiny side, and then we have the negative side, the dark side of the mirror. Let's go ahead and draw a normal line. A plane mirror is a flat mirror like you have in your house. And so flat mirror like you have in your house. Let's go ahead and draw a ray coming in. That's the incident ray coming in. Then we have the reflected ray coming out. And what we learned in the lab was that theta I, the incident angle, is the same as theta R. We measure those angles from the normal. The normal is 0 degrees. And those angles should match there. We use a technique called ray tracing, and this allows us to construct images. And we can do that by, with mirrors and lenses to look at it. And it lets us describe what happens to light as it interacts with the medium. So the law of reflection then states that the angle of incidence equals the angle of reflection. So theta I should equal theta R. If we have a plane mirror, we properly draw our normal line, those two angles would be the same. So this is going to be a critical slide. If you want to put this in a special spot in your notes, and then after you write this out, to put it in a box, and so we're going to keep referring back to this. We describe images based on three things. First, it's the nature. It could be a real image or it could be a virtual. It would be one or the other. With flat mirrors, we always get virtual images, and we get actually a flipped version of ourselves when we look at ourselves in the mirror, and we'll do that. Orientation is either upright or inverted. So if an object is upright, it's right side up, inverted upside down. And so mirrors and lenses can do that. It can flip things upside down or leave things right side up. And then the size, it can be the same size if it's true, enlarged being bigger, and then reduced being smaller. And so we're going to describe our images based on these, and you want to put this probably in a box in your notes. We're going to keep coming back to this again and again as we describe our images. So the image that we're going to use here is an object in front of a mirror. So you can draw an object, you can draw your mirror, and we're going to construct what this object looks like in front of the mirror. Now this arrow could represent your hand, could represent a face, whatever. And light is going to be coming from it, hitting the mirror and bouncing off, and by tracing that, we can follow what happens with the light and do that. So let's go ahead and draw then, light coming from the object, bounces straight back. Then we can draw one going towards the normal line, which will then bounce down like that. And what the rays are doing is they're diverging, and you're going to want to write that out after you draw it. So it bounces back, and it goes down like this. So these two rays are diverging. So what we do is we extend the rays behind the mirror like this, and then our image shows up behind the mirror. Now, this is kind of strange. Now, if this was, let's say, your face here, and you're looking at yourself in the mirror, and let's say that you're, I don't know, 20 centimeters from the mirror. It turns out your image is located behind the mirror, also 20 centimeters from the mirror, so a total of 40 centimeters from the mirror would be how far you are from your image. And so, and I want you to do this, so next time you look in the mirror, look at yourself and think about where your image is in relation to where you are, and you can look at yourself. Now, if you look at yourself in the mirror, and let's say that, you physically grab your right ear, what you're going to see is your image is going to grab their left ear. It's a virtual image. It's virtual because it's on the dark side of the mirror, it's on the negative side of the mirror, and it's a flipped version of yourself. So actually, when you look at yourself in the mirror, you're looking at a virtual image of yourself. It's not like a photograph, but it's a virtual image of yourself, and which is, again, really kind of strange there. And so yeah, there we go.